Light is fast, but just how fast? Let's imagine a blip of light leaving the sun right now. And let's see how far it gets into our solar system as we dig into this lesson. So, what's the subject? Well, we're going to define the light year and give it some perspective. The light year is the basic unit that astronomers use to measure the vast distances in space. Here we go. A light year is the distance light travels in 1 year. It's far. Why? Because light travels so fast. 1 light year equals about 5.9 trillion miles, or 9.5 trillion kilometers. That's not million nor billion. I'm telling you trillion, which is a million. Also, very key, a light year is a unit of distance, not time. A light year is a unit of distance, even though it uses the word year. Okay, so how's our blip of light doing? Wow, look at that. It left only 60 seconds ago, and it's already a third of the way to Mercury. This distance we might call a light minute, which is the distance light travels in 1 minute. Pretty far on a human scale, but quite small compared to the size of our solar system. I'll go ahead and tell you, Earth is about 8 light minutes from the sun. Traveling at about 300,000 kilometers per second, it takes light from the sun about 8 minutes to reach us. So when you look at the sun, you're seeing the sun as it was 8 minutes ago. If the sun suddenly went dark, we wouldn't know it until 8 minutes later. The farthest planet from the sun, Neptune, is about 249 light minutes from the sun. So light minutes is useful on the provincial scale of our solar system. Outside our solar system, the distances are far more vast. For example, the next closest star system to us, Alpha Centauri, is about 2.5 million light minutes away. So rather than talking about how far light travels in 1 minute, it becomes more convenient to talk about how far light travels in 1 year. The distance to the Alpha Centauri system in light years, that's about 4.4. It takes light from our sun about 4.4 years to reach Alpha Centauri. Here's how far all the stars within the Big Dipper are from us. Let's look at that Orion animation again. Look, all these bodies are within about 1,500 light years. Interestingly, most all the individual stars you can see on a clear night without binoculars or a telescope are within about 5,000 light years, which is but a small portion of the entire Milky Way galaxy. How big is that? Our galaxy is about 100,000 light years across. The next major galaxy closest to us, Andromeda, is about 2.5 million light years distant. The light we see from the Andromeda today, it's about 2.5 million years old. So you thought you were clever in understanding that all the stars you see in the night sky are not the same distance away from us. There's no celestial sphere. Now you know something deeper. The stars we see at night are not only separated by distance, they're also separated by time. In the Orion constellation, you're looking at Bellatrix as it was 250 years ago. But at the same moment, you're looking at the Orion Nebula as it was about 1,300 years ago. That's it. Next up, we'll take a closer look at the stars themselves and how it is we can discern their nature based upon 2 very important characteristics, which include color and luminosity. Good science to you.